so we've had some questions on our battery setup, okay? Started to disconnect this obviously already, but then I realized I probably should go ahead and make some video of this. So the stock Dodge Grand Caravan has a fairly decent battery. It's a fairly good sized battery, fairly robust. The car already comes with a small inverter in it, so it's built to run an inverter to run, you know, all the electronics that are in it. So I mean, it has a pretty decent sized battery in it to start with. Now, because we don't spend a lot of time dry camping, I didn't think it was necessary to have a separate house battery and the chassis battery. So because of that, you can see I took then and ran our house wiring just from the stock battery through a 50 amp circuit breaker and then in through the firewall. You can see where it goes in through the firewall through a rubber grommet that I put in there, and then back down through the chassis or through the interior to the cutoff switch and then the inverter. The system has worked pretty well for what we need it to do. Runs the blender, runs the inverter for small things like that. It cannot run the microwave. The microwave is big enough that it will not run the microwave just on battery alone. It doesn't have the power to do that. But the Dodge Grand Caravan also comes with a 160 amp alternator. So between the alternator and the battery, it could run the microwave for a short amount of time without draining the battery. But you have to be very careful then that you don't drain the battery out, that you don't run out of power and not be able to start then the van. I always kept the jump box in there. There was a little USB jump box always plugged in, so it was always charged in case then we were to run the battery down. But either way, it just wasn't quite enough. So I didn't want to run a house battery still if I don't have to. So the idea then is we're converting this then to one of the Odyssey deep cycles. So this is the Odyssey 31M PC 2150. This is a much more robust battery. It is a deep cycle battery. It can handle 400 deep discharges past 80% without damage. It has 205 amp hours of reserve capacity and should be able to sustain us again for what we do, since we do not dry camp a tremendous amount. Now in comparison, you can see the batteries are very similar in the footprint as far as overall size. However, the Odyssey battery is about 2 inches taller. So that's going to be the next challenge, to figure out how to mount this and accommodate for that. But you can see the stock battery, 730 cold cranking amps, reserve capacity is 140, which is actually pretty decent. Again, it's a big size battery. The biggest problem is just not a deep cycle battery. It's not made to deep cycle down, so if you run it down enough times, you will ruin the battery pretty quick. So that's the biggest problem with that, is it's just not a deep cycle battery. So a dual purpose deep cycle starting battery should be better. All right, so here's the battery in. It's actually a deep enough bay. I tipped this handle up and shut the hood to see where this would end up at, and it ends up actually clearing by, you know, so much. So it's actually got a few inches of clearance. So actually this battery will fit in here just like it is. Now it doesn't have the same tie down as the stock battery does, so I'm going to have to come up with a battery strap for that. But I mean, that's actually going to work out just fine. I'm going to have to lengthen this a little bit so it'll fit better, but the ones that I put on for the interior batteries should just bolt right up on there, and then the same way within the negative one should bolt right up on there. So I think it'll work out just fine. Alright, so here's the new battery installed. There actually was plenty of clearance here from mounting this in the stock position. It clears the hood with no problem. So basically what I ended up doing is the stock ground fits just fine, and then I put the ground to the chassis like so, where it should be, and then the other side is the house battery, and then here is the 50 amp fuse, And then I took the house battery and just ran it up top. It fit just fine. The chassis battery connection, I just pulled it out a little bit and then modified the stock part. This bolt comes through all the way and knocks out, cut it off, and then it mounts like so. That is not on the other side of the 50 amp, so it's not fused. It uses its own fuses. For the tie down, I took out the stock mount where the bolt goes through, pulled that out so I could put a J-hook through there. I drilled one hole into the plastic down on the other side so I could mount the other side, and it mounts up just fine. So there's the upgrade to the Odyssey. It doubles the capacity on the battery and gives me a deep cycle battery, so we can spend more time on the battery alone without worrying about having the battery go dead and not be able to start in the morning. I do have a battery monitor inside so I can tell the voltage, and that way if I have to start the van in the middle of the night, I can. We have a remote start so I can just start it and it charges. It actually charges fairly quickly on its own. Obviously all the other things, having it plugged in, the charger, onboard charger will keep it charged, so forth. Again, the reality is we spend most of our time on the road or just staying one night. We don't do a lot of dry camping. If we're at a campground, we're plugged in. So this battery is really just to give us a little extra reserve when we are stopped overnight. Now that we got the battery installed, I figured this is a good time to do a quick overview of the electrical system itself, kind of how it works. We've had a number of questions on those things, so I thought a nice overview would be worthwhile. So obviously you can see how the battery finished out installing. And we have then two connections. We have then the house connection, which goes back to the cutoff switch in the back, and then the chassis connection here. The chassis connection then runs through its own fuse panel, obviously. The house connection then runs through this 50 amp breaker and then back into the inside of the van. You can see down in here, it's hard to see, but that's where the two battery cables run, plus then the 120 cable runs down through there also. The 120 connection on the van is right under here. This is just a waterproof connection. I ordered it online, and basically you just drill a hole into the bottom of the bumper, and that's where your then extension cord can plug in. It is waterproof once it's closed, and it has a waterproof seal on the top, although it doesn't have to be perfectly waterproof just because of the fact that this is exposed sometime anyway, but the electrical connections stay dry that way. And then it runs up through here, along in here, and then joins up with the battery cables running through the hole in the firewall through a rubber grommet into then the interior of the van. Alright, so now we're inside the van, and this is where then the cables run from the engine compartment into the interior. Basically, it's hard to see without crawling all the way up in there, but it's right next to the stock wiring harness where it goes through into the engine compartment. And then I run the battery cables then down through this side here. They come underneath this kick panel. This kick panel just snaps off, and then underneath here, this panel here just pulls up like so. And then you can see here's the negative cable there. Underneath this rubber, basically just pulls off. There's then the hot cable. So it's protected nicely. There were actually little plastic joiners in here that kind of bridge this gap. I had to cut those out to give me the room to run that through there. But you can just see how these just snap into place. And then they run back underneath through here. There's plenty of room then in here. And then to get to the back, I drilled two holes in this interior panel here, down here, and that's where then the battery cables come then out and join up into the back here. All right, so here's all the components we have then here in the back. And like I said, you can see the battery cables come through there. The hot cable then goes to then the kill switch. I have a kill switch in here that cuts off the battery power to the rear, or to the van, okay, and not to the chassis, but just to all the components in the house portion of it. So that way, when we're driving, if we're not using the back, I can turn that off, but there's nothing that can drain the battery when it's sitting overnight, so forth. And then also, next to that, we have the Noco Genius which is a 10 amp battery charger. That battery charger then is always plugged into the 120, which is right next to it. Basically, I took an outside box and I mounted it to the wall. The power that comes from the front of the van goes into that, and then obviously there's only 2 outlets, so I needed a splitter because I keep the refrigerator plugged in at all times, and I keep the NOCO battery charger plugged in at all times. And that's so anytime I'm plugged into shore power, the NOCO will then charge the batteries, and the refrigerator will run off of 120 instead of the battery power. So then I have a Rhenology 3000 watt inverter. So it's a pure sine wave inverter. And basically what I do with this is I have then it plugged in here. This plug then is to a power strip that I have all of the rear electrical components that run off of 120. They're all plugged into that power strip. That power strip basically is then mounted up underneath here. So the microwave, the DVD player, the outlet are all plugged into that. So that way, if I go to shore power, all I do is unplug this and plug it into the open slot on the 120 there, and that way, that's how I switch back and forth to shore power. They do make, obviously, switchers that will automatically switch back and forth, but we don't run offshore power that often to where it's a big deal to actually just unplug that and plug it back in. I also have then smoke detector, carbon monoxide detector. I have a 12-volt fuse panel, so anything that runs off of 12 volt out of the back, which then I just have it coming down, obviously, to the hot side of the kill switch. I'm sorry, to the switch side of the kill switch. So that way when it's off, again, the things in the back that are not part of the normal chassis would then be shut off and not drain the battery. I have a cigarette adapter or cigarette lighter adapter there, and that's because the refrigerator, the plug-in, runs off a 12 volt through a cigarette lighter. I could obviously modify that plug, but I don't want to just because I want that plug to stay the way that it is in case we ever use it or move it to something else. There's the overview on the electrical system. Hopefully that helps you understand better kind of how we have it wired. You know, why we did the things we did as far as choosing to run just a chassis battery only instead of a house battery and a chassis battery. There's many ways to do this, obviously depending on what you're going to use it for, whether you're going to dry camp a lot, whether you're just using it to travel like we do, will make a difference on which you choose. But for us, this system seems to work out very well.
Next up, on the next video, we have a Q&A just to get all the questions answered in one video. And this finishes this one. Check out the other van build series and comment below. Later.